Okay. So do you have any doubt from last class to any of you?
No, sir.
Okay, we had started uniformly accelerated motion in circular path. So next is non-uniformly accelerated motion or circular motion. For non-uniformly accelerated motion, there will be time-dependent position, or in this term, angle. So you'll say acceleration in this part will have some variable term. As like we did in third chapter, that is motion straight line. Similarly, we can find here first instantaneous angular velocity. So it will be omega equals to d theta over dt, where theta is angular displacement. Next is, if you have to find instantaneous acceleration alpha, it will be differentiation of angular velocity, that is d omega over dt. So it will be applicable if omega is t-dependent function, and if omega is theta-dependent function, then use alpha is equals to omega d omega over dt, in which omega is theta-dependent function. Similarly, we may find average angular velocity. So it will be theta final minus theta initial divided by t final minus t initial, if theta is given in terms of. Similarly, we may find average angular velocity as omega times dt divided by dt. Similarly, average acceleration will be equals to omega final minus omega initial divided by t final minus t initial. So these are some formula related to which we have to solve different problems, which is similar to what we did in third chapter for translational motion. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay, just write it down. You all have written?
Yes, sir. Done.
Done, sir.
If theta equals to t square minus 2t plus 5, find angular velocity and acceleration at 2 seconds. Try to solve using the above concept. Since you have theta, so just differentiate it. Put the value of t, you will get angular velocity. So omega will be d theta over dt, and angular acceleration will be d omega over dt. Try to solve using these two formula.
Sir, I sent the answer. Done.
Good, Khalid. If you simplify it using this method, we have t squared. So on differentiation, it will be 2t minus 2, as 5 is constant. So on differentiating, it will be 0. So if you put t to be 2 seconds, you will get omega is equals to 2 into 2 minus 2. So 4 minus 2 will be 2 radian per second, which is unit of this angular velocity. Similarly, to get this alpha, we may differentiate this angular velocity, so which is 2 as constant, keep it outside. T on differentiating it will be 1. 2 is constant term, so on differentiating it will be 0. So alpha will be 2 radian per second squared. Is it clear? Hamza?
Yes, sir.
Similarly, in this part, try to find average angular velocity between t is equals to 1 second and t is equals to 2 seconds. Try to solve. First, t initial is 1 second. Put this in this theta to find theta initial. Similarly, put t final as 2 seconds to get theta final and then apply the formula. Try to solve.
Sir, we have to find theta or work?
First, you have to find theta using this initial time and this final time. Then average angular velocity. This is omega, not W. So average angular velocity equals to theta final minus theta initial divided by t final minus t initial. So you have to find theta initial by putting the value of t as 1 second and theta final by putting t final as 2 seconds. Try to simplify.
Sir, is the question related to the previous question?
Yes, with this one. You have to
Okay.
use this theta. If you put t is equals to 1 second in this part, you will get 1 minus 2 plus 5. So 5 plus 1, 6 minus 2, it will be 4 radian. And now if you put t to be 2 seconds, it will be 4 minus 4 plus 5. So it will be 5 radian. Now put these two terms in this part, you'll get 5 minus 4 divided by 2 minus 1. So it will be 1 radian per second. Good, Salman. Good, Khalid. Hamza, is it clear?
Yes, sir.
Hiba, any doubt?
No, sir.
You all have written?
Yes, sir.
Okay. So these are some dynamics of circular motion, which are some introductory part. Now let's start application of these terms. So first is concept of centripetal and centrifugal force. Suppose a body is going along this path with some velocity u. Whether its direction would change by itself or it would need some external agency to change its direction. Hamza?
Sir, it will need some external force.
Good. So we need some external force to change the direction of any moving body. So let's say a force is applied to its motion perpendicular to it along this direction. Since it is going initially along this path, so a force is applied along this direction. So resultant of these two terms will become like this. If you further apply perpendicular force to it, its direction will further change to this direction. And if force is keep on applying on this path to change its direction, so on. So finally, it will start to move along this circular path. So you will say a force which is responsible for keep on changing the direction of moving body so that it start revolving along circular path. So since this force is acting from inside, or that is towards center of that particular circular path, so this force is termed as centripetal force. So centripetal force is a force which is responsible for keep on changing the direction of a body so that finally start revolving along circular path. That force is termed as centripetal force. Is it clear?
Yes, sir.
It may be of any origin. It would be gravitational force, it would be electric force, tension, or any term. If its action is behaving to change the direction of a body at each instant so that it start revolving along circular path, then that force is termed as centripetal. A force which keep moving a body along circular path, or a body which is responsible for changing the direction of a body at each instant so that it starts revolving along circular path is termed as centripetal force. Now, as we know, if you change state of any object from its natural tendency, we had defined in chapter number 5 about inertia. So we have mainly 3 different types of inertia. One is inertia of rest, inertia of motion, and inertia of direction. So we'll say, according to inertia of direction, all object will tend to move along a straight path if there is no external force acting on that body to change its direction. Is it clear?
Yes, sir.
So due to inertia of direction, at each instant, there will be a pseudo force which act on that particular object to move it away from it or away from that circular path. That pseudo force is termed as centrifugal force. Is it clear? So centrifugal means a pseudo force which acts on every circular moving object to move it or tend to move it away from that circular path is termed as centrifugal force. Is it clear, Hamza?
Yes, sir.
So you'll say a pseudo force which will tend to move object away from that circular path and why this is acting so due to inertia of direction is called centrifugal force. So is it clear? What is the difference between centripetal force and centrifugal force? Hiba?
Yes, sir.
Yes.
Okay, just write it down to this part. You all have written?
Yes, sir. Done.
Okay. I'm giving you some example in relation of this. Suppose you have any circular path like this, in which it is connected by any string. So if it starts revolving along this path, so at each instant, its direction will be changing. So you'll say there will be a tension in this string towards center. And since it is revolving along the circular path, so there will be a pseudo force which must be acting on this body to move it away. Or in some other sense, you will say here tension is responsible for keep on changing the direction of the object to move along the circular path. So it will be behaving as centripetal force. Is it clear?
Yes, sir.
In this part, we have a body which is tied to a string having some length L or radius R. So you will say in this part here, tension is responsible for changing the direction of body at each instant. So it will behave as centripetal force. So it will be centripetal force. So how to calculate centripetal force? As we defined in last part about centripetal acceleration. So centripetal acceleration was velocity square over radius. So if you multiply it by mass, you will get centripetal force is equals to mass times acceleration. So it will be mass times velocity square over radius. Since in this part, we can say tension is responsible for keep on changing the direction of the body. So it will be behaving as necessary centripetal force. So it will be equals to mv square by r. In one sense, you will say this part. In other sense, you will say, since the direction of body is keep on changing at each instant, so there will be a pseudo force which tends to be acting on this particular body to keep it away from that circular path. So there will be a centrifugal force which is responsible to move it away from the circular path. That's why if you break this string at any instant, it will fly off tangentially due to this pseudo force. So it will be centrifugal force. Is it clear?
Sir, can
Yes,
you
sir.
repeat again?
Okay, just 1 minute. In first sense, you will say tension is responsible for changing the direction of object at any instant. So it will be behaving as necessary centripetal force to change the direction of the body. That's why I have written tension is equals to centripetal force, which is equals to this term. In some other sense or opposite sense, you will say, if you break this string, this body will fly off tangentially. Why it have moved along this tangential direction? So you'll say at any instant, it must be acted by a pseudo force which is responsible to keep this body away from the circular path, or which is tending to move this object away from the circular path due to its direction. That force is termed as centrifugal force. So you will say net force on this particular object at this instant will be 0. There is one force, that is tension, which is acting towards the center of the circular path. And there is one force, centrifugal force, which is acting away from it. So these two terms are equal. So tension will be equals to Fc. In either sense, it will give you same result. Is it clear?
Yes, sir.
I have just defined there are two different ways of defining centripetal force and centrifugal force, or how to relate these two terms. You may use the concept of centripetal force. You may use the concept of centrifugal force. But you have to use any of them one at a time. Just write it down. Do you have any doubt in this concept about centripetal force and centrifugal force and how to use it? Khalid?
Sir, will the formula of both of them will be same?
Yeah. They are differ only in the sense of direction. You will say if source is towards center, then it will be termed as centripetal force. But in all sense, there will be a pseudo force which tends to move body away from the circular path. That will be centrifugal. So it depends upon your choice, whether you use centripetal or centrifugal. Have you all written?
Yes, sir.
Now, depending upon these terms, I'm defining you first. Banking of road. First, what do you mean by banking of road? Suppose you have a track or a circular path. So that circular path get uplifted from outside. Let's say this is your horizontal point, and the inclination of this particular track from outside at some inclination theta, due to which it will be now more stable to move on the circular path. I'm defining you related with any diagram. Suppose there is a vehicle which is going along the circular path, having inclination this theta, so it must be acted by several forces. First, by gravitational force along this direction, and a force which is perpendicular to this plane, that will be normal reaction. If you draw a vertical line to this path and a horizontal line to this path, this will become theta. So normal reaction may be split into two terms depending upon this theta. So it will be n cos theta in this part and n sin theta in this part. Now let's assume there is some friction in this particular track, so which must be acting along this direction to keep this vehicle towards center. So if you draw a horizontal line to it and a vertical line to it, this theta would equals to this term. So using this, it will be f times cos theta and it will be f times sin theta. Is it clear?
Yes, sir.
What I have done here is, since you have a circular path like this, which may have some radius, so I have just raised this outer line from its horizontal level to this path. It have raised along this at some inclination theta, so that component of force which is acting towards center prevent it from skidding it away from the circular path due to the action of necessary centrifugal force. So it must be acted at any instant by necessary centrifugal force away from the circular path. Now, at this instant, this vehicle is moving in equilibrium, so net force on this body will be 0. So what do you mean by banking? So you'll say the inclination of curved road from outside, so that to prevent it to skid away is termed as banking of road. The inclination of curved path from outside to prevent it from action of or to overcome necessary centrifugal force acting on the body. Is called banking of road. So we may derive velocity of revolving as net force acting on this body is 0. So first I'm taking horizontal forces. We have in left hand side n sin theta plus f cos theta, which is responsible for balancing mv square by r, the first term. Similarly, we have n cos theta equals to mg plus f sin theta in vertical direction. So if you move f sin theta to the left-hand side, it will become n cos theta minus of f sin theta equals to m times g. First, write it down to this part.
Done, sir.
Hamza, done?
Yes, sir, done.
Okay. Now, if you divide these two above equation, you'll get on dividing n sine theta plus f cos theta divided by n cos theta minus f sine theta equals to m and m cancel out. So you're left with velocity square over g times of r. Now we have to further reduce this expression, for which divide each term by n cos theta. So it will be n sine theta divided by n cos theta plus f times cos theta divided by n cos theta whole divided by n cos theta divided by n cos theta minus f sine theta divided by n cos theta equals to velocity square over g times of r. Now in this first part, n and n will cancel out, and second part, cos theta and cos theta will cancel out. In denominator, n cos theta and cos theta will cancel out. So we're left with as frictional force equals to mu static times normal reaction. So frictional force divided by normal reaction equals to mu s. So if you put this term in this part, you will get tan theta plus mu static divided by 1 minus mu static times tan theta equals to velocity square over g times of r. On rearranging it, you will get velocity is equals to gr times tan theta plus mu static divided by 1 minus mu static times tan theta whole root under. So this is the safest velocity or the maximum velocity with which a body or a vehicle should move along this track. Is it clear? So this will be maximum velocity of a body. You may be asked to find V minimum. And this V minimum, friction will act opposite to its motion. In this part, I have assumed friction is acting on this particular object towards center. So for minimum velocity, it will be acting away from the circular path. So for that term, you will get V minimum equals to GR times tan theta minus of mu static divided by 1 plus mu static into tan theta root under. Just the reverse direction of each term. Okay. Is it clear?
Yes, sir.
Okay, just write down. You all have written?
Yes, sir.
Depending upon this formula, we may generalize it or summarize from this part into two terms. First is if track is flat, or for flat track, theta will be equals to 0 degree and tan 0 will be 0. So velocity will be GR times mu s root under. And next is bending of cyclist or plane. In that case, there will be no friction in that particular object or acting on the particular object. So mu s will be 0. So velocity equals to GR times tan theta root under, or you may write it as tan theta equals to velocity square over G times of R to find angle of bending. So just remember only this formula and you'll get this formula as well as this formula from there. Is it clear?
Yes, sir.
Just write it down. You all have written till this?
Yes, sir.
There is a question. A plane flying at 80 meters per second bends at 7 degree. Find the radius of that path. Take gravity to be 10. Try to solve. How to solve it? Just use this formula. Tan theta equals to V square over G times R. So R will be V square over G times tan theta. Tan of 7 degree will be equals to 7 into 1.74 into 10 to the power minus 4. No, it should be minus 2. Since in this part, theta is very small, so we can write tan theta equals to theta, and theta must be in radian. That's why I have multiplied by 1.74 to convert degree in terms of radian. So if you multiply it, it will be 7 into 4, it will be 28, 7, 7, 49, plus 2, it will be 51, and 7, 7, plus 5, it will be 12. 2 digit in this part, 2 digit in this part, so it will be 0.128, or you may write at 0.1, tan of 7 degree. Just put the values in this part, try to find. Okay, good. Hamza, just check your calculation. In this part, if you put v square, that is 80 into 80, gravity is 10, and tan of 7 degrees 0.1. So this 10 and this 0.1 will cancel out. So it will be 6,400 meter. Is it clear, Hamza?
Yes, sir.
Okay. Next is motion in horizontal circle, in which first is pendulum clock. Suppose you have support at this point, and there is a vertical line for reference. a bob is connected with this string, which having mass m, so that it will be allowed to move along this circular path like this at fixed inclination with vertical, that is theta. So this physical body is termed as conical pendulum. Or you say this one. Now we have to find certain term in this part. Let's say length of a string from this point of axis to this point is L. Mass of body or bob is M. So it must be experiencing an outward force due to its motion along circular path. That will be centrifugal force. Vertically downward due to gravity, so it will be mg. And in this string, there will be tension opposite to this point of contact like this. So if you break its component along this path and along this path, if this is theta, so this will be theta. So this will become t cos theta, and this will become t sin theta. So if you compare them, you'll get t sin theta equals to fc, that is mv square over r, and t cos theta equals to mg. So if you divide these two terms, you'll get tan theta equals to v square over g times of r, which is similar what we have derived in the above part. Is it clear?
Yes, sir.
Now let's say radius of the circular path from this point to this point is r, and we have to find its time period around this motion. So time period equals to total path length divided by its velocity. So using this triangle, you will say sin theta equals to perpendicular over base over hypotenuse. So it will be r over L. So r equals to t times sin theta. If you find velocity from this part, it will be gr times tan theta. Put these two terms in this expression, you will get 2 pi r divided by v, which is root under gr times tan theta. We may write it as 2 pi root. This will become r square, so it will be r times g tan theta. Put the value of r to be L sin theta and simplify it. L sin theta divided by g, and we may write tan theta as sin theta divided by cos theta. So this term and this term will cancel out. So you will left with time period equals to 2 pi L cos theta divided by gravity. So this will be time period for conical pendulum. Is it clear? Khalid,
Yes, sir.
any doubt?
Yes, sir. No, sir, no doubt.
Just write it down.
Done, sir.
Done, sir.
Next is motion in vertical circle. Suppose you have a body which is going along this circular path. So the body must require some minimum velocity to complete this vertical circular path. So we have to define tension, velocity of body at each instant. So let's say this is lowest point. At which velocity of body will be VL. This will be midpoint. So body will be moving along this direction with some velocity Vm. And this is highest point at which body will have VH velocity. So we have to find velocity and tension minimum condition for completing this vertical circular path. Body is connected to a string and start revolving in vertical circular path of radius, let's say r. So first at highest point, at this highest point, it must be acting or acted by one, that is tension in that string. Second, gravity, mg. And since it is revolving along circular path, so at each instant, there will be a force which tend to move it away from the circular path, that is called centrifugal. So you will say mv squared over r equals to tension at highest point plus mg. So what would the minimum condition to revolve along this particular circular path? So you'll say at highest point, object with slightly slag and then comes down to move along the circular path. Due to that slagness, tension at highest point for minimum condition would equals to 0. So now if you compare m times vh square over r equals to m times g. M and m will cancel out. So you will get velocity at highest point equals to gr times root under. Is it clear? Thumbs
Yes,
up?
sir.
Okay. Just write it down till this part.
Sir, line second, left, first word, what is it?
Okay. A body is connected to a string and start revolving.
Okay.
Done, sir.
Now, if you have to find velocity at lowest point, using conservation of mechanical energy, total energy at highest point must equals to total energy at lowest point using conservation of mechanical energy. At highest point, object will have kinetic energy as half mvh square plus potential energy m times gh, where h is twice of radius, which must be equals to, at lowest point, half mvl square. And since this lowest point is at horizontal level, so height will be 0, so potential energy will be 0. Now, if you put the value of VH from above part in this, you will get half m times gr plus 2 times of mgr equals to half mvl squared. So if you simplify it, you will get velocity at lowest point will be 5 times gr. Is it clear? Hiba, is it clear?
Yes, sir.
we may define tension at this lowest point. Suppose this body would experiencing tension along this direction, let's say TL, due to force of gravity, mg in this direction, and due to centrifugal force, which is away from the circular path, Fc. So you will say tension equals to mg plus Fc, which is mvl square over radius. So if you put the value of VL as 5 gr, you will get 6 times mg as net tension at lowest point. Khalid, any doubt?
No, sir, no doubt.
Okay. You all have written?
Yes, sir.
Hamza?
Yes, sir.
Similarly, we may use conservation of energy to find velocity and tension at middle point. So at midpoint, if we relate energy at lowest point and energy at middle point, as we have total energy at middle point as half m, velocity at lowest, square plus 0 potential energy. For midpoint, it will have half mv square. Mg height of body at middle point would be just r. So if you put the value of VL as 5 times gr, and if we simplify it, half m 5 times gr equals to half m Vm square plus mgr. Move this term to left hand side. You will get 5 over 2 mgr minus mgr equals to half of m Vm square. On simplifying, you'll get Vm equals to 3 times gr root under. Similarly, you may find tension at this point. Tension will be along this direction. Force of gravity will be along this direction. And centrifugal force must be acting away from the circular path, so it will be along this direction. So in this term, you will say tension is balancing necessary centrifugal force only. So tension at midpoint equals to Fc, which is equals to m Vm square over radius, and that will be just 3 mg. So you have to remember these 3 terms, that is velocity at lowest point, midpoint, and highest point. I'm giving one shortcut formula to remember this all, okay? Just write it down. You all have written?
Yes, sir.
This is your center. A body is at this instant, which is inclined at some angle theta with vertical. So this body will have some velocity v and some tension T. So velocity at this instant will be root under 3 times mg bracket (1 plus 2 times cos theta). And tension at this instant will be 3 times mg 1 plus cos theta. So how to relate these two formula to find the above term? We have 3 terms. One is lowest, second is middle, and next is highest. So for lowest point, put the value of theta to be 0 degree. For midpoint, put theta to be 90 degree. And for highest point, put theta to be 180 degree. So if you put these values in this equation, theta is 0, so cos of 0 is 1. So it will be just 1 minute. Cos 0 is 1, so 1 plus 1, 2. I've done a little mistake. Three plus 2 times of cos theta. Okay. So if theta is 0, cos 0 is 1. So 3 plus 2, 5. And there will be no mass. GR times this. So you will get 5 times GR root under. If you put theta to be 90 degree in this part, cos 90 will be 0. So 2 into 0 will be 0. So you're left with 3 times GR root under. And if you put theta to be 180 degree, cos 180 is minus 1. So 2 into minus will be minus 2. 3 minus 2 will be 1. So it will be just GR. Similarly, if you put in this tension, cos 0 is 1. So 1 plus 1, 2 into 3. So it will be 6 times mg. In this part, cos 90 is 0. So it will be 3 mg. And this part, cos 180 is minus 1. So 1 minus 1 will be 0. So just remember these two formula and try to find according to any problem.